consider it to be. Yes, there's a lot.
All right. Welcome, everybody, to this nth TWed of the spring 2026 season. Thank you very much, Nippon, for volunteering to do this talk today. We are not having probably not having a couple weeks. Next week is the GM week Wednesday. We try not to schedule anything for that. And then the following week, I don't know, we may or may not, I'm not going to be around in the UK. But we probably will have one or two additional TWeds before the end of the spring term. With that, take it away. One logistical question. Are you welcoming questions during your talk, or would you like to barrel on through it?
Yeah, let's barrel on through.
Okay.
Yeah.
All right. So thank you very much.
Yeah. Thank you, John. So thank you all for joining. So I'm Nipun. So basically, this is a research that I've been working for roughly 5 months. So the research is basically the SUDO KG, Discourse-Aware Scholarly Knowledge Graph for LLM era. Basically, to start with what the talk about. So the talk, as you imagine, primarily based on scientific knowledge graph construction and the knowledge graph construction. But in this research problem solution specifically, I had to went into pretty nuanced linguistic theories, basically discourse representation theory, rhetorical structure theory, and indirect argumentation modeling, and finally speech act theory. So I will roughly mention how these been involved and why did I choose this, and before going further into the whole presentation, what would be the expected outcome? So in general, this research would introduce a fully automatic discourse-aware scholarly knowledge graph modeling. I don't want to say this would be the first one, but I haven't seen any scholarly knowledge graph construction mechanism with discourse, which is able to run on fully automatically, and which I will explain why is it happening and everything in later slides. And second, for the neuro-symbolic AI folks, this paper would introduce bidirectional multi-step neuro-symbolic KGC pipeline. And finally, for the LLM reasoning people, we are missing actually the most important one, Srihari. This proposing representation modeling introduces an interesting idea of semantic reification inside knowledge graphs. So finally, in the preview, so the research will introduce only 6 or so neat tools and introductions. First one, SUDO ontology, scholarly upper discourse ontology, and ICO, elocutionary commitment act ontology, SUDO KGC pipeline, SUDO KGC MCP server and service, which hasn't conceptualized or implemented yet, planning to. And so 2 other kind of neat products or tools that I built over the research. One, to visualize KG instances, either with or without ontology itself, and view the ontology isolated or with KG instances. Just upload internal file, JSON LD, RDF, OWL, anything. Second one is KG adaptation tool, which is highly specialized for the proposing ontology, but can be generalized, I think. But it's cool, kind of introduce and this a hack that you can update on a PDF without extracting anything and re-render the same thing, but it's just a hack. So we've seen the preview of the presentation. So in the later slides or next slides, I will go through the background of the research, how scholarly discourse representation is needed, and knowledge graph construction, evaluation, final, the future work, and conclusion. Thanks. So first of all, we need to understand what scholarly knowledge graph means and its objective. Primarily, scholarly knowledge graph are there to connect or compose the publication metadata such as venue, authors, authorship, institute, and so on with the concepts, the information that introduces or uses within the paper, which basically you can see in this like red dot as a concept, which is the most popular way so far that large scale knowledge graph been using to represent the internal knowledge. And the second, third, and for most important part is connecting the paper that we are interested to the like broader scale scholarly scaffold with the discourse representation. So the ideal version would be of this scaffold is the structure would be able to explicitly represent networking of idea in terms of relay, like the evolution and interaction between literature, because like it's how we like perceive papers and understand over the like course of reading many papers. So going a little bit about evolution of SKGs is basically borrowed from my RQV. So we can see scholarly knowledge graph being there for more than 2.5 decades, and the research trend being highly influenced by the predominant like the trending research structures like semantic web paper or the Stanford NLP toolkit. But the interesting part is, even though it's been almost 5 years, to this day, the GPT-3 kind of the first large-scale language model introduction, but we haven't seen much LLM-oriented knowledge, scholarly knowledge graph construction. So this is what we are in a way trying to solve. And also this like evolution is kind of interesting because it is divergent. Evolved over 3 tracks to just to give information. First track like mainly focused on metadata primarily, and the citation network in like middle track contains metadata but mainly introduces the idea of concept modeling into the like metadata structure. And finally final one is the scientific knowledge graph construction that I will get into the details in later slide, and which is the key in this whole research. So when we talk about large scale knowledge graph, I believe most of you are familiar with these kind of products that you probably use daily or have heard about. So scale knowledge graph such as Google Scholar, Semantic Scholar, Amine is kind of niche one, but is pretty good application. And OpenAlex is the like rehash of the MAG, Microsoft Academic Graph, that's been there till 2021, and later niche version of knowledge graph is CSKG. But since these are primarily built on metadata network and citation network, like representation, these large-scale knowledge graph are primarily used on 2 tasks. First one, the researchers or the institution profile discovery, and the second one is very important, keyword-based course-grained publication discovery. Because of this reason, to search on these kind of large-scale knowledge graph for a specific paper or a specific area, you have to know the keyword related to that area. You just can't search on the lexical free or scenario based searching. But with the introduction of LLM, now that lexical gap been almost dissolved, because now you can search without area specifications or purely based on keywords. And I'll explain why this being like intuitively made it capable by LLMs. And the second part is because of the same reason, now like we can search with nuanced detail and practical and scenario based setup rather than just keyword based search. So in general, to so far, like this problem being solved in twofold by LLMs. Before MCP and tool calling, like LLMs primarily like use their trained frozen knowledge, and with the introduction of tool calling and popularization of it, now like this LLM-based knowledge graph interfaces are using SKG APIs to retrieve information and then derive answers. So before going into this SKG AI API calling, we have to look into this like what happened earlier. because we should kind of appreciate it, because like LLM hasn't, like, even at that time, even LLM is able to like derive some sort of like holistic view of an area or the semantic relationship between papers. LLM hasn't seen all papers together at any time of training. See, LLM only has seen one paper at a time because of this whole processing happens on common set of weighting. Like LLM internally model these implicit relations. So as a human, this is almost the same way that we are doing, but the problem is LLM is as good as what it has been evaluated. So this is the main reason LLMs are good at some times, and they are highly unfaithful at some prompting. So, but it's just like this very interesting idea that I am borrowing to build the explicit representation of the semantic relations or the discourse scaffold. So the second part is how modern LLMs work, basically using the APIs. So we already defined LLMs are excelling at the in-context information processing, and it's increasing day by day. But with the tool calling, now the performance bottleneck draw down to one, how good LLMs are selecting and calling tools. Assuming it's okay, the major problem is SKG API tools, because like as I mentioned earlier, these SKG API tools are pre-LLM. They haven't updated or specifically modified into LLM support. So what I mentioned by that, basically, as I mentioned, LLMs are good at first understand conceptual representation internally in a paper and also build the implicit discourse scaffold. So to make LLM to harness that in the tool, SKG itself should be capable of representing one, concept modeling, two, most importantly, explicit discourse scaffolding. So we are mainly interested in the second part. Why? As you would see, most of the existing SKG types such as scholarly knowledge graph, academic knowledge graphs are already like representing the concept structure with the metadata, but are not explicitly deriving or representing the discourse scaffold. But there's a type of scholarly knowledge graph called scientific knowledge graph. They derive this like discourse scaffolding. As you can see here, like this is very famous paper, SEMS. So it derives given a paper, what is the approach, what are the evaluations, how did it implemented, and so on and so forth. But the main problem with these scientific knowledge graphs are they are not large scale knowledge graph to use at like automated manner or use be under the LLMs. So now we have to address why is it not like scalable. Mainly this is like draw down into the like knowledge representation modeling issue, as I understand. So this is the this pink track that I earlier mentioned that we are interested in primarily in this paper. So like I'm like talking about two aspects again. Before Gen AI, or even with or without Gen AI, the core problem, as I mentioned, is the modeling of scientific knowledge. As you would see in the sensor ontology itself, the discourse or the concept representation is highly derived. For example, there's no like single entity or statement itself defines the approach. You have to connect multiple statements to build the whole approach, likewise evaluation and implementation. And also the discourse structure is very abstract because as you again see, the ontology is pretty abstract structure. And also this is highly domain dependent. And finally, the proposing the knowledge representation requires global semantic inference. Let me explain. So like In a paper, this like approach and evaluation related statements like scattered across multiple paragraphs and even multiple pages. To build accurate and complete approaches, like whatever the system that you're using has to look over large domain or large context, or it should be able to do global semantic inference. So that's what I mentioned. So just imagine now we have Gen AI. So it is to some extent capable of doing everything because ultimately they are generative AI. So, but the main problem is with this augmented information generation, it's very hard to guarantee the groundedness, which basically means faithfulness to the original text. Why this is important? Because ultimately we are planning to use this knowledge graph as a supporting or the source information for the LLM. So if we are making that source information is already generated by generative AI, so this like information corruption is cascading. So therefore, we have to guarantee, or we have to have some sort of guarantee, this like generating knowledge graph is grounded or faithful to the original text. And the provenance also, it's kind of simple because as long as we are using LLMs to track provenance, we have to do full text search over the all entities that LLM generates. That's not efficient. And next we go into efficiency. Either like we can put all to like at one and get the whole knowledge graph, then that would probably cause low completeness. But if you're going with very like controlled pipeline manner LLM, because LLMs are very power hungry, computation hungry, and time costly, so the system won't be efficient enough to work as a MCP server. So it would be okay to work in a passive knowledge graph, but again, like ultimately, like papers are producing like very rapidly. So if we are planning to build a static large knowledge graph, okay, that's not a good approach. So the solution. First one, we are planning to trying to introduce new scientific knowledge graph modeling ontology or approach that captures concept structure, also model the discourse in a propositional structure without text augmentation or derivation at all. The second part is because of these like non-derivative forms of like scholarly discourse representation, now we would be able to build a fully automatic knowledge graph, which is efficient, almost near zero augmented. Near zero comes basically because of we have to anyway inference the classes and build the canonicalized relation. So it kind of augmentation, and the tracking provenance finally striving for the completeness. The completeness basically defined as high precision plus recall. So before going into the detail of ontology modeling and the knowledge graph construction, let's view the conceptual or the information difference between just pure concept modeling and the approach that we are proposing. Okay, so here you are seeing a concept graph that is built on very famous attention all you need paper. In a way, this kind of to some extent capture the core idea. I mean, if you know the abstract, these make sense, because if not, it kind of doesn't make sense. Attention mechanism used for encoders, that doesn't make sense. But in the statement, they say you can use attention mechanism to connect between encoders and decoders. Okay, you see the information loss, but in a way, it connects the concept. But now let's look into the proposing full discourse structure. So this is what we are planning, and what is the difference between this pure concept graph and the discourse-aware knowledge representation. So starting from the first, I'd say the statement, it should be up above somewhere. Yeah. So this is the first node, the elaboration. So as you can see, the statement, that's an elaborative statement, bit among how convolutional neural networks, encoders and decoders are intrinsically connected to sequence transduction. That's why like these like elaborative proposition connect with these concept nodes with elaboration relation, and then we go into the approach. Let me show the yeah. So nice. So like this is the core. They define the approach as of like introducing the transformer, what? Yeah, motivation or mentioning the recurrence and convolution architectures, and which has evidence, as you can see. So, and then when we go into the evidence, now this evidence connected with claims. How the evidence being generated is represented by the connected concept structures, like such as evidence is basically running on the task of English to German translation on the matrix of blue and the material of WMT 2024 dataset. So, full disclosure, this whole knowledge graph or the thing that you are seeing is fully automatically generated. So this is what we are striving for, finally, actually strived for at this point. So coming back into the presentation, so now it's kind of apparent like how much of an informational difference happened between fully discourse represented knowledge graph, scientific knowledge graph, and just purely concept knowledge graphs. So then like now it's good time to understand how to model this. So the idea behind is kind of simple. Basically, I try to represent how human perceived and build the global scholarly scaffold mentally while reading the paper. So basically, again, what we do when we are reading paper, at a statement level, we try to first classify between is this like core argument related or descriptive of whatever method or data set or something like definition, elaboration, it could be some anything. So like when we understand the internal like context of a paper, and when we read some paper that like also discusses same kind of entity, for example, attention mechanism, now we connect these papers using canonicalized concept representation. In that scenario, attention mechanism. So this is the whole thing. So basically, we have concept nodes, we have indirect argumentation modeling nodes, and concept description nodes. So that's all. But actually, like to build an ontology, or basically we are trying to build an uppercase ontology, we have to formalize the what indirect argumentation means, what descriptive node means, and what concept node or concept representation and the relationships build. To do that, I had to go for a linguistics, pretty deep and pretty old linguistics. So first of all, like the concept that I just derived, how human as us understand like the whole scholarly scaffold is already been theoretically defined in the concepts of conceptual semantics. Basically, how humans express their understanding of the world and through the linguistic utterances. So there are two parts: linguistic meaning of terms, and the speaker intent on the utterances. So basically, this whole thing derived in two orthogonal spaces. First one, considering the x-axis, it is information structure. Y-axis is the propositional structure. So, as I mentioned, current knowledge graphs are pretty good at developing the information structure as a concept graph. The two missing pieces are how to build propositional structure and how to connect concept graph with the propositional structure. So this is what we are trying to do. First of all, we are doing a tad bit of different or the update augmentation to the concept graph, because most of the concept, like the concept graph or knowledge graph that I mentioned, are domain specific. To make domain agnostic, we are going with concept classes that are domain agnostic and the lexical relations rather than the domain specific semantic relations. Luckily, there's a whole area of domain agnostic information extraction called SciIE, and there's a very good and very famous dataset called SciERC, which defines the taxonomy for the concept and concept representations. As you can see here, the relations are lexical. They are not semantic. Because of that, the whole concept representation and concept relation representation is domain agnostic, right? Which is one tick to making the pseudo as a uppercase ontology. Second part is propositional discourse structure representation. That's the actual novelty of this paper, the work, so, which internally contains three parts. One, how to classify or define the types of propositions. Second, relations between propositions, which basically define the propositional discourse structure. And the third one is the second key part, relationships between propositions and the concept nodes, which actually connects the two orthogonal axes, ultimately building the conceptual semantic representation into a scholarly knowledge graph. So, yeah, I'm kind of going a little bit fast on these slides because they are very dry on theory. But again, so to first model the propositional structure and classify propositional structure, there's a linguistic theory called elocutionary act and elocutionary force, which derives linguistic markers such as elocutionary force, degree of strength, sincerity, which basically means which basically developed as commitment act, and elocutionary point that we can use to guide LLM to properly classify the intent or the discourse of an statement. The second part is high level classification, because as we've seen, like now we have not just statement, but we have argumentation statement versus descriptive statements. To model these, there's like another very famous linguistic theory called rhetorical structure theory, which basically defines three concepts. How rhetorics, basically the elementary discourse units, for example, clauses or statements, are related to each other, or how they are causally constructed, and finally as whole schema of it. But most importantly for this research, they introduces the core idea for separation between argumentation relations, argumentation statement versus descriptive statements. Because in the rhetoric relation representation of that rhetorical structure theory, they derive two types of relations. One, subject matter, basically descriptive relations. Representational relations defines the referential relations, which basically derived into our required forms, descriptive propositions and argumentative propositions. So to show what descriptive propositions, what kind of descriptive propositions would this RST build or proposes, as you can see here, types are elaboration, circumstances, solutionhood, and etc. As I remember, there are 11 types. And because of this, using the same RST theory, now we have relations between discourse propositions and the related concept nodes, because that's primarily like proposition describes the core concept, or in RST, satellite describes the nucleus of the rhetorical structure. But the second part is how to model argumentation. So assuming or representing a scientific publication as a scientific experiment, now we have to model scientific experiment in an indirect argumentation modeling technique, which actually introduced by Tuleman way early, I think like it's 1970 something. And I'm actually augmenting the Tuleman's argumentation modeling using SWAN IOC, SIOC ontology and SEMSA to build the following representation. Basically, we have an idea, or we have ideas to solve or to respond to issues, and the ideas and issues primarily derive an approach. So approach uses to build evidence which proves final and ultimate scholarly claim, and which has few like qualifiers or like the extra features such as quantifiers, basically which defines in what setting that claim is true, and the rebuttal on backing and warrants. So basically the warrant is the one that connects the evidence to the claim using the context semantics or the context knowledge. So ultimately, the discourse knowledge, our proposing SUDO, Scholarly Upper Discourse Ontology, would look like this. As you would imagine, this is a multi-tier knowledge modeling. At the top tier, we have argumentation nodes. In the middle tier, we have artifact node, and the lowest tier, we have description or descriptors. And as you can see, the relations between those tiers and inside each tier. So to look into how these been actually realized in our extracted knowledge graph, let's filter. So let's first look at the argumentation modeling. So argumentation should have argumentations, claim, evidence, and approach. We go. So as you would see here, approach build evidence, and evidence prove some claims, and here the key missing parts are ideas and issues. It's not that common. Every paper has complete argumentation modeling. As long as there are connected argumentation nodes, it's enough to build the argumentation representation. And also this is the interesting part, because like using the aspect of argumentation modeling alone, we can classify papers. For example, survey papers won't have any argument because it's just descriptive nodes. And likewise for the idea papers or positioning papers, it would only have issues and ideas, or probably approaches. It won't have the claims, evidence, and other parts. So it's kind of interesting, but also, like as you would see, like it's not complete always. So the second part is, I don't think we have, we have a descriptor node. So descriptor nodes, where is that? I don't know. So other main relation type that we modeled is the connection between proposition nodes and the concept nodes. As you can see here, the proposing model derived the RST, or the rhetorical structure theory, mentioned relations, and they are like evidence generation being enabled by the GPU, and also that's been contextualized in the scenario of the task. So like broader scheme of things, this is how the proposed pseudo ontology is being realized or populated into a knowledge graph. So getting back into the slide deck again, so now we need to learn first of all, why pseudo proposing knowledge graph is able to solve the aforementioned issues. First issue that we've seen is like the existing psi KGs are requiring derived information. As you would like learn just few minutes before, proposing a knowledge representation model does not require any derivation to build the propositional structure, because it primarily works on sentence levels or sub-sentence level called finite clauses. And also it will define or derive the discourse structure without using abstraction, because now we are working on linguistics introduced by lexical structures introduced by a couple of linguistic theories. And it doesn't need any global semantics for the discourse representation, because again, the proposing or the using linguistic theories are running on local structure primarily. So we can just rely on the local structure, but again, like ultimately the argumentation like structure would be scattered, but after all, we have the argumentation modeling. And finally, and most importantly, proposing the pseudo knowledge graph or the pseudo ontology make it enables fully automatic knowledge graph construction. So the next question is why? First of all, in very simple terms, the proposing knowledge representation or modeling like schema is pretty simple, because the lexical units are noun phrases and finite clauses. The propositional classification is primarily driven by linguistic markers that we are getting from elocution react theory, rhetorical structure theory, and all the other parts. And proposition concept relations also derived from the discourse structure that we are building. And finally, we can even do like but propositional gating before doing some semantic operation to like what control the operational time rather than going for n squared, that I will mention in very soon. So, and going to the one key introduction that I mentioned at the prefix. So we see in the proposing pseudo ontology connects propositional nodes into concept nodes. But if we look at that relation in a different perspective, basically concept nodes are nodes and propositional nodes are also connecting concept nodes into a single propositional node. Just imagine now that propositional node is the reified relation between all the concept nodes under it. So if we transform that propositional node into an like latent structure, basically we build the embedding, now we can do semantic reifications on that concept nodes, or like we can then extend that into semantic level reasoning across concept nodes, and sky is the limit, I guess. So this is the concept that I mentioned earlier. So now we have to go into the knowledge graph construction. As I mentioned earlier, we still have 4 requirements to satisfy. 1, completeness. 2nd, groundedness. 3rd, provenance modeling. And finally, the efficiency. So, first of all, what we can't do? We can't just rely on pure classical NLP or non-generative models, as it's like so apparent that model won't be complete. If so, that's been already done by some other researcher. And but like if we go with a fully LLM or pure LLM based approach, like this whole area of ontology guided knowledge graph extraction, it is complete, or it's like reasonably complete than pure like NLP technique, but it is not grounded or provenance being derived, and it's almost always non-efficient except you are doing one-shot triplet extraction. When I say one-shot triplet extraction, there's like very prominent research sub area under knowledge ontology guided knowledge graph extraction. Basically, you put a statement and get a triplet. It's just like not the way how human build knowledge graphs. So unlike that, because now we can't just purely work on like traditional pure NLP or pure LLM. The solution is to combine both. On the concept or the idea of high precision semantic refinement on high recall syntactic candidate set. So high recall syntactic candidate set would generate it pretty fast because it's syntactic after all, and the refinement can be done on semantic level to increase the precision. So, which basically means we are proposing multi-stage bidirectional neuro-symbolic pipeline for the knowledge graph construction. So the whole conceptual modeling of the proposing knowledge graph, the pipeline is pretty simple. I wanted to mimic how human would annotate the knowledge graph. As a human, I would try to first identify the candidate entities and try to check those candidate entities fit into the the given taxonomy or the ontology class set. So if it fits, now we have two other problems. One, we have to get the existing data properties for that fitted entity. So I'm not assuming the completeness, shape-based completeness, but we can assume it. And finally, when that node being popularized, we have to check for the inter-node relations. So the beautiful thing happening in here is, as you would imagine, this candidate extraction and the data property extraction depends on the context data. It doesn't need to have any inference or the generative part. But the classification of candidate entity or the canonicalized relation building need to have semantic inferencing, because that classification happens on it has to introduce new information. It's not just an extraction. So basically, now we see two sides. One, lexical extractions. Two, semantic canonicalizations. So these are the two parts of syntactic and semantic refinements that I am trying to derive. So basically, there are 4 stages. One, high level 2 stages, like candidate structure building and relation structure building. For each candidate structure building, we have syntactic high recall candidate extraction and the semantic high precision refinement, followed by syntactic high recall discourse structure building, so which basically means relation state building, and end with semantic high precision. But actual pipeline is a little bit complicated than that. So let's go with an running example to understand what completely happens in here. So I'm explicitly not trying not to get into algorithmic detail, just to show what kind of augmentation happens over the pipeline. So first, sentence segmentation from the given paragraph in here. Again, I'm sticking into attention all you need abstract, as we see in the demo. And sentence segmentation module would separate out the sentences, again using lexical rules. And then we separate sentences into propositional structures. Basically, here proposition means finite clauses. So in simple terms, clause that contains subject, predicate, and object, or subject, verb, object. Then we do open information extraction. As you would see here, in red colored one, other introducing new information in the pipeline. We extract or define the spans of named entities. So this is purely syntactic operation. Basically, try to derive adjacent consecutive noun phrases or proper noun phrases in the text. And third part is that little bit complicated in algorithmic sense, but it's pretty easy to understand. Local co-reference resolution, because in a when we see noun phrases, there are 2 parts. Some noun phrases are grounded noun phrases that can stand alone, but other noun phrases need to have a referential unit. To and grounded information, that's what co-reference resolution try to do. So as you can see here, we have grounded, in this example, we only have, at the very bottom, we have a co-reference resoluted one. Yeah. So then we go into the semantic candidate refinement, where we at one shot do 3 parts. Actually, this is highly pipelined DSPY based LLM refinement, but basically we do referential named entity refinement, grounded named entity refinement, and finally named entity classification. As you would see, the result would be like that. We would get classes. Basically, these are semantically semantic representation of the wrapped named entity, and also this like red color complex recurrent is and drop. As you could imagine, here we had that complex recurrent as a grounding node, and this grounding node refinement would detect, okay, that's not an very good grounded node, because if it was like recurrent neural network, yes, that makes sense, but it's just complex recurrent. And finally, this is that a linguistic marker generation is IOC attribute, ICO, elocutionary commitment attribute prediction for each proposition. We predict what is the force, what is the strength, torque level, polarity, and the modality of the proposition. Because at the later stage, these linguistic markers work for classification. As you can see here, this propositional discourse type classification primarily work on the like inferred propositional markers to detect this is an argument and which is a claim. So then we again get into the second phase of the knowledge graph construction, the discourse representation. The first part is argument to artifact canonicalization. Again, this is semantically required process. Because of that, we are using LLMs. And you can see the relations that LLM generated, defining what like the named entity is being contextualized in the proposition. Then we would derive artifact relations, as you would see in here, again, LLM-based prediction, LLM-based control prediction, and then we again move into a syntactic argument discourse gating. So the whole idea is this, okay, like as I mentioned, there are three types of relations: artifact, descriptors to artifact, there are four: argument to artifact, and the discourse structure only builds on argument to argument. So if we haven't done any gating, we have to check the like n squared combination space to check which like arguments are like discorsely connected to each other. So without going into this n squared operation, we can do gating on two levels. One connectivity gating, which basically means one causality based connections. Basically, you have to have an approach before evidence, because you will generate evidence based on an approach. So like that kind of causality I use for the connectivity gating, and the second one is predicate gating, which basically means domain range relation constraint based filtering, because like what proves connects evidence to the claim, none other. And then based on that, I'll do refinement on the argument discourse, but this is not LLM. Here I'm using NLI models for the entailment prediction rather than just classification, because ultimately it's just like given two statements, we should be like if they have an like expected relation, we can set the proposition into the hypothesis and put the relation into the premise and ask, would those two propositions entail the premise? And that's how we get the argument discourse. And then we do an like kind of additional step of refinement on arguments. As I mentioned, argument nodes does not stay alone, because if you just have the proposition or the approach, it doesn't mean anything, because we can have an approach as in a description or the elaboration. To have an argumentation, you have to have the connected structure. So therefore, we separate or we redact or all the like isolated argumentation propositions into an descriptors and try to predict the descriptor type. Yeah, that's what happens in here, and that's why we like make and that form a claim argument into an descriptor of elaboration. So all in all, this is how knowledge graph construction happens, and this is the exact pipeline that I used to generate that knowledge graph that you see. Finally, for the evaluation, again, I'm like fixing into the 4 requirements that I mentioned again and again. Completeness, I'm evaluating against bag of concept performance, which is pretty famous and also pretty bad, that I will show. And the node classification accuracy, again for the completeness. For the groundedness, we use node level hallucination detection that introduced with in the paper of text to KG by Professor or Dr. Nandana. Provenance and data quality validation using shackle or more specific structure of shocks to do multi-axis data quality validation. And finally, the efficiency just runtime analysis. I haven't done it yet. So one part. So all these data that you are seeing, or the performance result that you are seeing, primarily on a very small, basically 5 paper annotated calibration set that I'm still calibrating the whole pipeline. So first one. So like this is a bag of concept performance. I defined 3 forms, basically Levenstein text similarity with fixed and dynamic thresholds. As you can see here, like this is the core problem with bag of concept. It's just set intersection or union at performance or the scoring. So if you can set a dynamic threshold with the partial matching, you can clearly get a 1, but it is not the correct one. So because of that, and also like because of the set matching, that doesn't guarantee one-to-one matching. So in here, I have to derive a like kind of more stable form of a bag of concept performance using Hungarian bipartite matching algorithm, which kind of inspired by a paper called DRT, which is like image classification paper or object detection paper. And as you can see here, like which is pretty like stable, and also I'm not just using cosine similarity, I'm using node re-ranking model to derive the relation between or the similarity between 2 entities. So the current performance seems to be good, but I'm not that satisfied. This should be way better because like ultimately we are trying to strive for the full completeness. Specifically that you can see in the like node classification performance, it's like not that good. Specifically in the proposition structure, because like it's kind of complicated, and also like my annotation was pretty bad at that time, so I was like sleepy. But the interesting part is the groundedness and the data quality validation. So for the groundedness, I did the hallucination evaluation. So as you could see, in even with this like smaller paper count, we are not getting any hallucinations. I mean, practically there is no way, but like anyway, like we are evaluating it. But for the data quality measures, I'm evaluating again 4 axes. One, completeness, which basically means the expected discourse representations and the descriptors to concept representations. Basically, if you have an elaboration, that should have elaborate some concept. Like that's why we are getting lower score for the completeness, because some descriptor like propositions are not connected with concepts. And literal validation, which basically means English should be English from the literals, and provenance, because like we are defining the provenance as of from where the node being derived from exact context and what paper pro was generated, and pro agent to derive what version of the pipeline that's been used. And also finally the range validation, which basically validates the domain and range of relations. But again, this is not the actual evaluation that I'm planning for the final version. So which contains 3 parts. One, gold standard dataset, which would I derive from AMSR dataset, which is a open reviewer dataset, which has AKBC conference with 27 papers. It's kind of interesting because AKBC is academic knowledge base construction. automatic knowledge-based construction. And I'm planning to evaluate on, I'm planning to annotate all these 27 papers manually and run all those 4 axis, like requirement axis evaluation. But like to evaluate on large scale, I'm trying to or planning to introduce a similar standard set with like distance supervision. Basically, there's like recent evaluation method introduced called MINE, which evaluates the induced information completeness. So I'm trying to evaluate on that, and finally ablation study on the gold standard data set to show whatever the techniques under each step is the optimal. Hopefully I have enough time to do that. But yeah, so the future work, again, as I mentioned, I had to build the evaluation sets. To some extent, I have extracted most of it. I had to run the full notes, and most importantly, so far you've seen this whole knowledge graph construction within a paragraph. But to do that over a paper, we have to have global reference resolution that I have to implement. I mean, that I had implemented, but I haven't connected with the pipeline yet. But also we are trying to introduce another paper from this research as of a like resource paper, which ultimately build this into a like actual knowledge graph which connects across papers and canonicalize the concept nodes, basically global canonicalize using like CSO classifier, and also implement that as a potentially a MCP server and service, and also work as a post hoc like data representation to the semantic Scholar API for the paper metadata. And broader scheme of thing, we are also working on the knowledge discovery on the same like SUDO KG, which kind of we are on the path of like deriving how research being evolved and minimal contribution unit of a given paper, and also the concept semantic drift over the paper, over the research directions actually. And finally, this is an interesting idea that I came up over the like just come into my head. Why not do a latent knowledge retrieval? Because like right now we are just doing like we are embedding the like label or RDF label value of a node and check the cosine similarity, but which basically means we are losing a lot of information, data properties and the concept or the basically class ontology information and a lot of stuff. So but since we have this like semantic reification, we could probably do latent knowledge retrieval. I don't know, I just like an idea. And for the conclusion, we try to introduce fully automatic discourse-aware scholarly knowledge graph. I think we've been successful at that. And as you've seen, proposing knowledge graph is informational rich compared to the previous concept graphs. And then like with the in the middle of the research, we somehow came across this idea of semantic reification, and finally like the research introduces a NISI KGC pipeline for the zero or like almost near zero information augmented knowledge graph construction. And that's it. Thank you. Any questions?
Where to begin?
How many papers in the evaluation set?
Oh, 5 papers. You're asking about the current evaluation, right?
Yeah.
Yeah, it's 5 papers.
Yeah, that was the left-hand column of that.
Oh, I missed that.
I was looking for that when he hit that.
5 papers on one topic.
Although I was explicitly trying to make it like different as possible. So 1 paper on knowledge graph evaluation as a survey paper, 1 like position paper, 2 full research papers, and 1 short paper.
On what topics?
So they are mostly on knowledge graphs construction.
So the same topic.
Kind of, yes. So 1 transformer paper.
Well, if you threw out some medical research paper and engineering paper, and would that still work?
We hope, because the concept structure is generic enough. it doesn't contain domain information. But again, like it kind of depends on how good the semantic refinement is. Anyway, we would get the high recall like entity set, because in any domain, like this concept node represent as a proper noun or proper noun segment.
Yeah, I think I kind of understand what you're doing, but I don't quite get this discourse piece. So you mentioned dialogue acts, but I didn't see any in the examples,
Oh, so
anything out of that. I mean, so somebody disagrees with the what you claim or questions claim or.
I'm not using dialogue act to if I'm using dialogue act, yeah, that happens. I'm using speech act, which is like single indirect argumentation without any like callback, like in dialogue act. Basically, because within the paper they try to build an indirect argumentation means first define the problem and then give the claim.
Right, but what I'm guessing that one paper may argue that another paper is wrong about something, right? And so very often that is, you don't say, you know, the guy so and so is wrong. I am right. I mean, that's probably people don't say that, right?
Yeah.
They would say things like, you know, so and so this way, but this only works in this case, and I kind of agree with what they say. However, actually, I have a better solution. That is an argument against something. So it can be quite subtle, right? And you have to get that and somehow just have some kind of a weight to it. Is it complete rejection, partial rejection?
Oh yeah.
So it's really like conversation, except it's on long distance and indirect. Right?
Yeah.
People are not talking to one another, they're talking sort of indirectly, talking to some global audience by saying this guy is wrong. Okay, by being indirect.
Yeah.
Right. And I think I thought that would be most interesting piece rather than just extracting ontology, right? Out of, actually, I don't know what you're extracting. Is it an ontology or is it's an argument structure that you extract?
I'm extracting argument structure with the like connected concept node structure. So like I totally agree with you. Like if I'm only deriving the argumentation only, but like this like descriptor like nodes explicitly is there to like dull down this like global rhetorical argumentation, because after all, like as I mentioned, the ideal structure is how like ideas being evolved. So to do that, at least in this research, like we would imagine if we have the initial idea and the approach and the evidence and the claims and the couple of like tidbits like quantifiers and warrants would be enough. But also yes, paper also defines the like how other papers hasn't been able to do that, or like in very indirect manner, or like very cautious way. So that kind of statements goes under descriptors, like elaborations, contextualizations, causes, and so on and so forth. We preserve it, but we are not explicitly using that into the structure.
So I think it was somewhere around slide 50, you start doing that you start incrementally showing how you're building out
Oh yeah.
that kind of injecting the semantics. Do you have earlier when you were showing the graphs, the visualization in your idea star tool, Do you have like a visualization of that? So go to that around 50 or so when you start building. I think it was around 50.
Like here?
Well, yeah, you start in, you do your initial parsing and then you start building.
Okay.
Well, so a couple things. One, I think to your viewer, I'm pretending I'm last semester. Okay. I think it's really hard for us to see your red highlighting.
Yeah, I just realized.
So, if you did something like bold or whatever to kind of show how you're incrementally building out, that would help. Because it was really hard to kind of pick that out. I saw that you were doing it, but I crossed my eye.
In here it's
I'm impressed that you can see that. I cannot tell. Like knowing that it's there, I'm like, is it though?
I'm sitting 42%.
apparent in here.
Oh, wow. I guess that's because you should test out it's super visible on your screen.
Well, this is it's rule 3A. And it's, in your presentation forum, you should always check it out. But anyways, you can see my point.
Yeah.
How you want it.
I didn't even realize it.
But I mean, it's very cool how you're building out. But as you were doing this, what I was imagining is that you had like an incrementally constructed visualization.
It's the actual thing I'm seeing. Like
Yeah.
coding.
Illustrate that as you're going along. Okay. That would help. I guess I've gone down this path, so I should keep going. You introduce in passing a very novel tool, which we've never seen before, that visualization tool.
Oh yeah, that I will.
Yeah. That would have been worthy of an entire TWed by itself, okay? Because we've had this will be like the third that we've had in 15 years or 16 years. Okay, so yeah, when you got it, like, that's like, and as I'm going along in this war, I'm going to drop this bomb. See it. And the next thing. So this was a very innovative thing, which we should talk
It's
about.
ugly.
Not now, but it is basically it's an RDF viewer, right? A very
Yeah,
cool RDF viewer.
The generic or
it's generic. You can put any ontology on any like turtle instance.
Yeah, it's like the newest RDF viewer.
problem with RDF visualizers? It needs to be like parameterized
Yeah,
to show like specific entities or group of entities.
I've only ever seen one that I really liked, and Jamie refused to. It's like Apple making sure that old versions of iOS don't work anymore when they introduce it. So that you buy the new one. And Jamie introduced Wayas. All of a sudden, she didn't support RDF viewer, which is actually amazing. Which I'm reminded every time I give a guest lecture up the hill, I show demos from RDF viewer and say, I wish I still had this. Anyways, this is very, very cool. Do you have this in GitHub somewhere?
So yeah, like this has GitHub and already Docker build. I'm planning to build an image and put into the Docker hub that others can just download and run as a container. Nothing much.
So it'd be really cool to see this demonstrated with other examples.
Yeah.
How long have you had this around?
I mean, I had built this in the middle of, I just wanted to see the turtle file, so because of I built it.
Well, I mean, it's nothing really, really good like this exists.
No.
Okay, this is very unique. This by itself could be a resource paper.
Yeah.
Yeah, but you would have to have that faceted angle, or else it wouldn't plot.
Yeah, and I think for large graphs, it will also be a problem.
Well, I tried to make it scalable as it. So this is running on lazy rendering on D3.js with condos, condos triplet representation structure. behind it, and this is like what what is that like?
So,
Angular native.
yeah, so kind of, I think, in the interest, go ahead.
Just two comments. One thing is, I think if you know the schema, in this case, you know the schema because I have the ontology. You can have like an ontology driven plotting. So you maybe show the entities and then you can potentially see the instances associated with the entities.
Yeah.
So that helps. But if you don't, like that, right? So you have that already. But let's imagine you have a graph and you don't have the schema,
Yeah,
right? Which is comma, right?
like just put in the turtle file.
Yeah, any turtle file, a large one.
Can you still show?
This is large.
Not that large.
Well, I mean, that's,
I can
Yeah,
send
but if
you
you
some
have like
big
a large
ones.
one, you could have like, some embedding approach in place to extract common entities and maybe cluster the instances together.
Already been done.
Oh, you did?
Like, yeah, I can cluster by types, IRI, also like, it's like I have different view levels, like I can show complete object properties, annotation, properties and everything, or
yeah, this is,
But that's the ontology field, right?
no.
You still have the ontology field.
Oh, like this ontology view means like different levels of like ontology. Only the class structure plus object properties, class structure, object
I
properties,
think
data
that's
properties.
good enough, but, for graphs that have schemas.
yeah.
So, yeah.
Yeah, and I put it in the chat, but are you connected to any reasoner? So there was an ancient entity relationship browser early in the description logic world, and it was connected to a reasoner, and then you could see the updates being added to the graph, which was crazy cool.
Oh,
This has existed for what, like 2 months? Come on.
Well, but he's so fast and so energetic, maybe he'll do it.
Well, yeah, I don't think he can. I'm seriously, I don't think he's able.
Yeah, you could try to submit a resource paper just on that. You could
Yeah, actually, it would be interesting to see what kind of comments you get. I mean, I think you should think about it.
If you get accepted because it's like,
too simple.
yeah, I don't know if this is like of value anymore these days, but you can try.
Well,
If you don't get it in, it's definitely a demo.
So,
So,
yeah, well, yeah,
It might take off just like Wadoko did. I mean,
Yes.
Wadoko was pretty simple, but it really kind of took over.
Yeah.
oh, but yeah, but Doko was a piece of excellence. Well, yeah, so it would be really stupid if this got overlooked because like the semantic web world has existed for decades without really good drive up doors. And it's like, how does the semantic web do their work without having something really good? And so this is cool. I think in the interest of time, we should call it quits, but I did want to ask, can you talk about what, like, are you submitting this to a venue? You're doing a talk, a formal talk soon? Are you,
You mean the,
yeah, your work,
Idea of it?
not this, but your work in general.
oh, so that whole thing that I mentioned would go under as a full length paper into ISWC, and the MCP, the structure and the global categorization with the full connected knowledge graph go as a resource paper into ISWC.
Okay. That's pretty impressive. When this gets accepted, you're gonna want to figure out a strategy for it, because this is, your presentation kind of boils 2 oceans, or 3. There's a lot here.
Yeah.
And you're gonna have to figure out a strategy. And literally, it's too much for, I mean, you crammed it into a little over an hour, really quick talking, you zip encoded it.
Yeah.
You need to figure out a kind of a strategy for presenting this in a very concise way, but not missing anything. How do you, what are the headlines? How do you paint the pictures? And then some of the mechanics that we talked about last fall, in terms of helping your viewer keep track of where you are.
Oh, yeah.
Yeah, because they sort of need to be able to have these mental milestones as you go through. I'm here now, I'm here now. He's explained this now, he's explained this now. So kind of help contextualize as you go through each piece where you're at. I think that helps for long talks, it helps the user, it helps the viewer to figure out where you are.
Yeah, I try to get like bid from like the header that like Jane
I know.
uses,
But yeah, I mean, and I'm not saying your argument wasn't logical or anything like that. I'm not criticizing that. I'm saying when there's a lot, you need to sort of like, this is what we know so far. This is where we are in our story. Okay, kind of bring them back and say, now we're going to talk about this. You see,
yeah.
kind of have to take a break or kind of take a thing. The other thing to think of for this forum, for TWed, you want to think about how you might have discussions and stuff like that. I mean, it helps keep both, but it went to, we'd be still getting through the first section of the paper if we actually
It would
opened
be
it up.
hours.
Yeah. There's a lot here. And again, that's not a criticism. When you got a lot to talk about, it's hard to, so you did the right thing by saying, don't ask questions.
Yeah, but part of the sharing here is getting other people's ideas. So making sure to leave some time for questions is always a good strategy.